Let's see how to find out zero force members of a truss. In a truss, there may be some members which are used to stabilize the truss so that the truss are not unstable, but in reality the members are not carrying any load. So those members are called zero force members. How to identify those members? There are two criteria to identify those members. One is if two members are connected at a joint and there is no external force applied to the joint, then both members are, remember, both members are zero force members. This example, two members are connected at this point and there is no external load. So if we resolve the force in y direction, we get F1 sin theta equals 0, right? F1 sin theta equals 0, and which means F1 equals 0. And if we resolve force in horizontal direction, F1 cos theta plus F2 equals 0, which substituting this value here, we get F2 equals 0. So both of them are zero force members. The next case is when three members are connected at a joint. So in this case there are three members and there is no external force applied. Again, in this case also there should be no external force. And the third criteria in this case is two of the members are collinear. So if the members are not collinear, then we cannot say that if there are zero force members or not. But if the two members are collinear, in this example this member and this member are collinear, then in that case the third member is zero force member. So in this case not all but only one member is zero force member. Let's see an example how to determine the zero force member. Okay. In this truss you can see 800 kilonewton is applied at point C. So if you are trying to find out zero force member, point C has to be ruled out first. Now we need to see if there are any joints with only two members, which may be A and E, but without external load or support. So A and E has to be ruled out because there are external reactions at A and E. Now we need to see the second criteria. If there are three members and two are collinear without any load at the joint. So this means joint B has two members collinear and there is no external load and it has three members. So which means this member should be zero force member, and similar is the case with joint D. This should be zero force member because CD and DE are collinear at joint D and there is no external load at joint D. As we remove both of these members, the truss becomes like this. Now if we move to joint G, there are two members at a joint and there is no external load, which means both of these members should be zero. Similar is the case at F. There are two members joined, but there is no external load, which means both of them should be 0. So you can see here the figure. This one is 0, this one is 0, this one is 0, and this one is 0, which means our truss becomes like this. So we need to analyze or find the member force in AB, BC, CD, and DE. So these are the only members carrying the load, transmitting the load of 800 kN to the supports. Other members are there just to make the truss stable.